Hi, I'm Karl Burgess. I'm from the University of Edinburgh, and we've just kicked off a project in the last month on plant growth promoting rhizobacteria with a fertiliser company called Omnia in South Africa. Now, if you don't know what PGPRs are, as I didn't until relatively recently, if you're familiar with the nitrogen-fixing bacteria that help plants grow, there's a whole suite of these bacteria that can be used to enhance different aspects of plants and their growth, and also deal with tolerances to the environment and tolerances to stresses. And we're working with Omnia, who's a large chemical company, fertilizer company, as they transition towards a more bio-based and sustainable platform for plant growth in sub-Saharan Africa. So what they're doing is they're developing a bio-based fertilizer that can be used for maize, specifically designed to deal with the changing climate, to provide sustainable growth and to reduce the burden on the environment that the nitrogen-based fertilizers give it. But where do we come in? So I'm a Metabolomix guy. I'm basically a mass spectrometry geek, and where my speciality is in metabolomics, which is a bit like genomics. We're trying to look at the whole broad basis of a particular type of chemical, but in this case, we're looking at the phenotype, all the small molecules that the plants and the bacteria produce. And this is critical in this case because the bugs themselves produce all kinds of phytohormones. They produce nutrients. They fix phosphorus. They fix nitrogen. They do all sorts of things, and we want to find out which ones are the most applicable to the environment that we're growing these crops in, and also for these plants. So the idea is that we'll measure the plants themselves to see how they respond to the bacteria. We're measuring the bacteria themselves. We're looking at lots of different strains to see what the best mixtures are. We do mass spectrometry, analyze them, and we get these very complex data sets that we then look at all of the different parameters and come up with an ideal group of strains that we can then use commercially. So if we can start to move African agriculture away from chemical-based fertilizers and into bio-based fertilizers, we can help with sustainability for the future. We can try and push these towards communal garden projects and subsistence agriculture and smallholders and things like that to try and get even small farmers, small-scale farmers, all the way up to very large-scale farmers using these products. And as I say, we've only just started, but I think this is going to be quite exciting over the next 18 months. So thanks very much for listening.